60 days of data science. I'll probably only do 30 days. And most of this work is done by Nina Chakravarti. This is her Medium, and a lot of her projects are on here. And then just going over what Levin Tech has done over here. He's basically went through various of the 60-day data science challenges, and I've picked some that I've thought are kind of useful. And this is GitHub, and I'm just going to explain some things that were covered on here that I think are important to know. So this was an introduction to functions in Python. In Python, functions are a convenient way to divide your code into useful blocks, allowing you to control and order your code, makes it more readable. You can reuse and you can define interfaces and save time. Function can be called multiple times, provide modularity and reusability. The Python program can easily track a large Python program easily. When divided into multiple groups, there's two types: user-defined functions and built-in functions. User-defined functions are defined by the user to perform the specific task. Built-in functions are predefined. You can define the function using the def keyword. Arguments is the information that's passed into the function. Then we have the return statement, which is used to return the value. And a function can only return one value. Once you create these, you can call the function using the function name followed by parentheses. So there's private variables. These are when you create a variable inside a function. It's local by default. You can create private variables by using underscore before a name prefix. This is pretty helpful when you're letting subclasses override methods without breaking interclass method calls. So you can see that this is a private variable here. You have a single underscore. You have a class test. It's defined and initialize this information right here with the self and number. And then it's basically saying start with the number. And the private method is basically defining a numbered function with the self. You can see that this comes up twice. And you're printing hello. And the object is test. So it's calling this function up here. And it's trying to print out the numbers 156. You can also have a double underscore. You can see double underscores here. And you have class test again, which is very similar. Self dot underscore underscore num is here, and then it's printing in this format for this function. Okay, you can also have trailing underscores, which is also listed here. This is coming after, and this is showing 3 different ways you can have functions here. We also have global and non-local variables in Python. When you create a variable inside a function, it is local by default. When you define a variable outside of a function, you basically, it's global by default. So non-local variables are used in nested functions whose local scope isn't defined. Global variables are those variables which are defined and declared outside a function. We can use these inside the function, or we can use global keyword to make a variable global inside a function. So this has local variable. L is defined as a local variable and return 1, and then this variable is for test. So you can see the local variable was printed out. In the top example, hello was printed out. Down here, if you have a variable of 10 and you define this test as a variable of 20, it'll print the local variable. And then you can check it. So first it printed 20 as the local variable, then it said value is test, and then it said print the global variable, which was 10, which was defined up there. So it depends on where your variable is located. Like this is the local one and the global one's on the outside. You can have first class functions in Python as well. So a function in Python is a first class function if it supports all of the properties of first class objects, such as assigning it variables, which is used without function parentheses. Functions are objects you can pass as arguments to other functions. First class functions allow you to pass around behavior and abstract. And then you have closure functions, which are functions that are nested and can carry forward parent function state with them. Here's another implementation of the outer and the inner function here. So the outer function is A, the inner function is B. Then it says return B plus 10 and return the inner A. So if A is 10, the variable is the outer, then you print the variable outer, and it's printing 20 here. So it basically did 10 plus 10. So A is 10 got put there, and then B got added in, and then we got 20. So the import function, there's an inbuilt import function which helps to import modules in runtime. It's underscore underscore import underscore underscore, and then you have name, globals, locals, from list, and level. Name is the name of the module to import. Globals is the dictionary of the global names used to determine how to interpret the name in a package. Locals is the dictionary of local names used to determine how to interpret the name in a package context. And then we also have from list, which gives the names of objects or submodules that should be imported from the module given by name. There's also levels, which specify whether to use absolute or relative imports. And then to import a module by name, you can use import lib or import module. Here's the implementation. The abs method is defined in the math module, which returns the absolute value of a number. Math score is equal to underscore import, and then you have math, globals, locals, and the other variables are defined, and then it printed out 17.4. Tuple unpacking with Python functions. So in Python, tuples are immutable data types. Python offers a very powerful tuple assignment tool that maps right-hand side arguments into left-hand side arguments. And then this mapping is known as unpacking of tuple of values into a normal variable. During the unpacking of tuples, the total number of variables on the left-hand side should be equivalent to the total number of values in a given tuple, and then it uses a special syntax to pass optional arguments. So if you define the result as AB, you can return A plus B. Functions with normal variables are listed like this, and you can have a tuple, and then it's passed. So these are the values that are listed here based on the code. So you define the result as AB, returned A plus B, then you print the result as 100 and 200. So if you add these, you'll get 300, which is what we see down there. Then over here, it's going to be 100 plus 300, which gives us 400, and it's printing that result C. Then we have static variables and methods in Python. So static variables are the variables that belong to the class and not to objects. Static variables are shared amongst objects of the class. Python allows providing same variable name for a class static variable and an instant variable. Static method in Python shows that they're methods which are bound to the class rather than an object of the class, and they're called using the class name and not the objects of the class. So static methods are bound to the class. So we have a static variable 25 printing the test.static variable. If you do an instance for test and you write ins.static variable, it'll still be 25. You can change with an instance. Ins.static variable is 14. So basically it started off with 25, it printed 25 again here. Then when we in the instance variable, which was right here, it printed out 14. And then it accessed through the class and printed out the test static variable, which is 25 at the start. And we have the static method. It's just written with an at, and it's defining this message. So it'll try to print triangles are welcome to the sample shape class. And this is how you use the at portion. Thank you.